All right, these are very quick problems, really. If you look at what we have to work with here, there's 4 functions. Um, they're all in graphing form already, conveniently enough. So to say which functions have 0 roots, it's hard to just look at them without getting a quick idea of what's going on, which is why I have this workspace down here. So f of x is equal to this. We know that the vertex is at -1, -5. So a quick sketch of that. I go back 1 down 1, 2, 3, 4, 5. I got a dot there which represents my vertex. Now this one's got a negative in front, which means it's really just going to be dumped upside down. So conveniently enough, I have the first one I tried actually has 0 roots because it's below the x-axis and it opens downward. So f of x is going to be one of my solutions here. The proof, hey, why not? I mean, you've got this little guide, 1, 2, 3, 4, 5. You already did this. You know the basics of the fact that where the vertex is located, which direction it's pointing. That's proof enough for me. You can also plug in, I don't know what else you could do. There are other ways, but I think that's a pretty good way to do it. So in our workspace here, let's look at g of x. G of x has a vertex, and I would say that people have been doing this wrong because they're not really paying attention to whether there's parentheses or not, or where they be. I often encourage my students to write this out, x minus 0 squared. Make sure you see h and k. If you rewrite that equation with the understanding of where h and k should be located, that's the k there, and this is the h. So the vertex is at 0, -1. Okay, 0, -1 is right here if I use that same graph. This time though, however, it's a positive 1 in front, so it's going to open upward. Lo and behold, we have 2 solutions. So which ones have real roots? Well, g of x does, among maybe others. And the quick proof, to have one graph that you can put a couple parabolas on, I think you got plenty of space for each of these. Down here in my workspace, I'm going to try probably and use a couple. I don't need to squeeze them all over here, but we got plenty of room to maneuver here. H of x is 1/8 x squared. Now, again, if I were to rewrite h of x, that would be 1/8 x minus 0 squared plus 0. There's no plus or minus anywhere. Okay, this maybe helps you see that the vertex is at 0, 0. Because right there, some of that's hidden, and some might want to try and use the 1 and the 8. Anyway, it opens very wide. That's the a value talking. But it doesn't really matter. In terms of the roots, it has 1 root because the vertex is on the x-axis. So h of x has 1 root. We've got 1 of each so far. Bada bing, there's your proof. But we do have this equation here, and k of x equals x minus 2. If I put k of x here, and I've got x minus 2, that's in the parentheses, so I don't have anything outside. So my vertex is at 2, 0. 1, 2, maybe that's exaggerated a little bit. 1 and 2, okay, let me do it there. There's your other vertex. I didn't go up or down, I just went to the right 2 units. It also opens upward. And the fact that it opens steeper, you can show that here, than your 1/8. Again, it's not going to make a big difference one way or the other. You end up having a parabola that's sitting on the x-axis. So h of x, I didn't give myself much room for the other answer. K of x is the other. Okay? No solution because it never touches the x-axis. 1 solution for each of these because they're sitting on the x-axis, the vertex. 2 solutions because the parabola hits it twice.